Hi, folks. Thanks for standing by and welcome to today's presentation, Building Radiant AI, Lessons Learned on Applying Large Language Models in Identity. During today's event, attendees will be in listen-only mode, but if you have a question, you can submit it anytime using the Q&A button located toward the center of your screen. Questions are private and will only be made viewable by the event staff. We'll be addressing questions during the presentation as well as at the end if we have time. And any questions we don't get to, we will compile and send to John for review. Also, feel free to interact with the chat panel. So chats will be visible to all event attendees and discussion is encouraged. Lastly, CPE credits will be emailed directly following the conclusion of this event. Now, I am very excited to introduce our featured speaker today, Dr. John Pritchard, Chief Product Officer at Radiant Logic. John, please go ahead.
Thank you very much, Heather, and a very warm welcome to everyone attending the Identiverse webinar series. This is quite possibly my favorite event of the year, mostly because it's a practitioner conference. We get to discuss a lot about the how. And today I'm going to be sharing some of the how of our own experiences in building and integrating generative AI into identity and the making of Ada, our AI data assistant. I think there's going to be something for everybody today. So if you are an identity professional and you're evaluating technologies, I'll give you some questions to pose against your providers around what to look for and how they've implemented some capabilities. If you're into the service delivery, I'm going to talk about where data specifically for identity fits in the larger IAM ecosystem. And if you are a technology producer or a product company like we are, I'll share some of our lessons in pulling AI technologies, all the innovations that have been happening in the market, and how that's been applied into our own product development. Talk about what worked and share some things that didn't work so well. For today's session, I'm going to break things into sort of four sections. I'll start with a view on the current threat landscape, some of the problems, I guess, as we're dealing with in the identity sector. This is going to suggest opportunities for us in terms of AI capabilities and really things that we've been struggling with as an industry. I'll then give a perspective of how those opportunities could be solved or addressed or perhaps helped with AI types of capabilities. And then we will get into a demonstration of our own implementation of Ada, talk about a specific application of that use case, go through some examples, let you see some of the capabilities in action, and then showcase the role that AI, identity and access management and data, as they all come together, can perform in the industry. And then I'll wrap with some lessons learned. Again, we'll talk about this journey we've been on. This represents about 1 year of work for my organization. This happened at a time where the innovation in the market's been rapidly changing. We began this effort candidly before ChatGPT was a thing. And as that innovation sort of hit the market and generative AI became a capability that was really mainstream in terms of integration capabilities, we adopted a lot of that. There's a lot of lessons here in terms of AI capabilities, different types of machine learning techniques. So I'll close with some of that lesson and to give you some takeaways as you evaluate technology as it's evolving in the future. All right, so let's begin. So firstly, from a perspective of the market, I think we can all appreciate that our classic perimeter defense is no longer really fit for purpose given the world we're living in. And every organization that we work with, I think, is defending on a very broad surface against many types of attack threats. We've implemented a lot of technology to protect our enterprise assets and our organizations, things like access management, single sign-on with multi-factor. We've got lifecycle provisioning in place. We are doing much deeper technologies around privilege access management. Some organizations are maturing into aspects of zero trust. And what's striking for me is that even with all of that investment as an industry, we still see just an enormous amount of breach risk that occurs to some of the largest organizations. And look, this is not simple. Some of the breaches that we've read about have been well-known brands, some even in the identity market. And I think it speaks to the challenge of running a large enterprise, because bad actors, they realize that they don't have to defeat every one of our defense techniques. Really what they're looking for is that one undermanaged or unmanaged account that can be compromised. And unfortunately, those exist in the large. Part of this is just the complexity of our enterprises. Candidly, part of this is just the amount of legacy systems we're still dealing with. So things like service accounts, local administration accounts, if you're a bad actor, you know that those are rich assets for you if you can discover them. Now, part of the reason that is such a problem is that we get sort of two contributing factors. On the one hand, there is a really systemic problem in the industry with zombie credentials. And this is our word for accounts that are still active, be those former human accounts or non-human accounts, for systems or people that are no longer in the company or no longer in active service. This is partially an artifact of the lifecycle deprovisioning problem that we have in industry. We've gone very far in terms of workflow automation and IGA integration with systems. But most every organization that we work with is still suffering, deeply from this sort of last mile problem with legacy systems that are still out there that have been fully integrated into their lifecycle management process. The other issues with insider threats, and these aren't always malicious in terms of the risk as much as compromised or negligent accounts, right? So this is where a bad actor is, through some process, taking control of a legitimate account and then using all the credentials and access and authorization of that account to maneuver in the organization. What we're trying to do is get to this goal where the right person has just what they need for the right reason. It's governed, it's monitored, and we're reducing the entitlement and reach and authorization of the systems that are running in our enterprise. Now, as an industry, we're doing all the right things. So we've implemented layers of technology that solve specific problems, be that single sign-on for access management, how we're managing our customer identities. We're implementing aspects of lifecycle management, looking at how we govern the permissions and entitlements of those accounts. All kinds of innovation happening in the privilege access management space, from early things around vaulting to sort of the ideas now around just-in-time provisioning, and then maturing into this sort of aspirational model of complete zero trust, where every access request from a user for a certain type of resource is validated. That's introduced a great deal of technology in our enterprises. And I think most of your organizations will look something like this, where you've got a collection of technologies, and those technologies are continuing to innovate and emerge. I was just at the RSA conference a few weeks ago. Huge event. The number of, I think, cyber and identity systems that are continuing to introduce the market continues to grow. We're seeing some really great innovations around threat detection and automation. But one of my key takeaways is that, if anything, our cyber stack and our identity world is not simplifying. If anything, we continue to add very specific technologies and capabilities to the stack. The issue, of course, is everything that needs to manage, connect to, or control. Because in most enterprises, there is a level of complexity that you are sitting on, which is just the nature of being an organization that's been around for a long time. On the data side, that could be all of the information about your workforce. It doesn't live in one place. You may have multiple directories. You may have training systems with data about your employees. If you've been acquisitive and you've acquired other organizations, you have their investments to integrate as well. On the customer side, you may have information about your customers living in multiple customer databases. And I think what we find is that the challenge of where everything lives in the enterprise and the connectivity to all the things we're trying to use to defend it results in a pattern that looks very much like this. So this combination of sort of sprawl, identity silos, and the ever-presence, unfortunately, legacy systems combines to produce technical debt and some hygiene problems. This contributes to this risk that we're dealing with. So you ask ourselves, okay, complex systems, lots of data, enterprise is very broad. Is this an area where different types of technological approaches could assist us? And AI is specifically skilled at this idea of reducing complexity and driving some insights. So we asked ourselves, what are the use cases here where there may be some opportunities to drive into some of these problematic areas? If if you talk amongst yourselves, or if you're at some of the industry events, you read some of the industry periodicals, the applicability of sort of data science, machine learning, and AI into our identity space, I think is well appreciated. I've taken a survey here from last year from the Identity Defined Security Alliance. Not surprisingly, when asked, you think there's a use case where AI and ML might be appropriate? 98% of the people said yes. If you start to dig in the use cases, though, you start to see where there's some opinions about how AI might be applied and where it's not best applied. And I would say there's sort of two takeaways here. Broadly, there's a belief that AI can help with complexity, looking at large sets of information and helping make sense of what I have difficulty sort of understanding. At the same time, I want AI to assist me in making decisions, but I have a concern about delegating the decision-making to those systems. So this sort of idea that I don't want an AI black box that is sort of like looking at my entire ecosystem and environment and then making autonomous decisions, I don't feel like the market feels like we're there yet. We still need humans making critical decisions. They are overwhelmed. There is lots of information they're having to process. So one of the big opportunities then is, can I leverage AI or machine learning techniques in the decision-making process? And so we broadly talk about this in how I look at identity from an analysis perspective. So think about that as all the work in the different roles in my organization, be that on the detection side or my governance side. As my organization grows, I have many more things I'm trying to manage and deal with. Do I have opportunities there where AI can assist me in the process? This perspective is actually held even more broadly if you take a look at the market. I've got a great quote here from Ariel Zeitlin. He is a partner with a firm that focuses on venture capital for the cybersecurity market. And Ariel makes a really interesting statement. He says that identity is where security is going and will revolve around going forward because there's so much more rich data there. And I think Ariel's on to this concept that as the cyber market continues to specialize and we bring more capabilities into the enterprise, the challenge is becoming understanding the connectivity of all these systems. So let me give you an example. If you think of in the past, in our security stance, we often would discover that breaches had occurred, honestly, after the fact. Something would have tipped us that we've lost something or there's been a stolen credential or stolen asset. And then we go through this forensics process where we're trying to understand what happened. That usually involved us getting logs, maybe from multiple systems. We're trying to do some correlation between those things. And eventually we piece together what sort of happened. If you fast forward to today, we're in a much, much better posture. We have all types of systems that are doing things like threat detection, but they're all emitting signals around risk. And if there's one common thing I think I've heard from our customers is that there's a lot of signaling systems, and you're watching these sort of risk ecosystems that form, trying to aggregate all those signals together. I think what's in front of us is this sort of next era, which I describe as sort of sense making. And this is an area where data science particularly is very strong, which is looking at lots of data, often real-time data, and starting to detect patterns, highlight where there are anomalies in some of those patterns, but inferring things about the relationship between changing data sets. One of the reasons I think that the combination of the evolution that we've had in hardware, things like GPUs, and this new evolution on the data science of software, things like large language models, are having their moment. We're at a point now where systems are honestly intelligent. They can look at very complex things and start to begin the beginnings of sort of reasoning about things. And we're going to talk about an example of that in some of my use cases here about how that's applied. But what I will leave with you in sort of thinking about where we are in the market is that I think identity, data, and AI are really having their moment, right? We're at a point where the systems are in place. We've got enough sensors that are deployed in our enterprise. They are looking for specific behaviors or events. We've got standards about how we talk between systems. We're starting to develop some standards about how we describe the eventing side. And when we start to bring all that together, we have this rich data set, which is the most important thing, as we'll talk about, for doing different types of AI-based inferencing. So if we think about the use cases then in the identity space, and I may broadly describe these in these sort of 4 categories. So authentication, are you who you say you are? Authorization, can you do the thing you're trying to do? And then sort of the administration and governance sides of running an enterprise. I may consider, okay, there are well-known problems across all of these. As identity professionals, we have been implementing these, automating these practices, putting in different types of technologies over time. We have areas where we know we still have problems, and we have areas where we are sort of seeing lots of innovation. So question 1 is like, what are the opportunities? And then question 2 is, what type of AI application may be appropriate here? AI is a very broad category we use sort of loosely in the data science space, but you can think about things like machine learning. You can think of things like specific algorithms or things like generative AI, which is most recently been talked about its ability to make sense and have natural language discussions in assisting us in our decision making. Each of those AI approaches have some strengths, and you probably are not surprised to learn that they're not appropriate for all types of use cases. Generative AI specifically is particularly weak when it comes to forecasting and predicting. In fact, if you read about some of the challenges in generative AI, you'll hear the term like hallucination. And that's the sort of description of when an AI gives an answer that seems plausible, almost defensible, but is actually factually incorrect. And there's lots of reasons how this occurs, and there are many, many techniques about how to minimize that accuracy risk. I'll speak a bit of those lessons learned towards the end of my talk as well. But sort of application decision number 1 is, what's the problem area? And then 2, as we've done for our entire careers, like select the right tools for the problem. And what you're going to find is that it ends up being more than one. And I'll share some of our architectural discoveries as well. But there's certain combinations that are turning out to be very powerful. So the ability to take, say, a machine learning algorithm, which is really, really strong at something like anomaly detection, and marry that with a generative AI type of approach, which is very good at sense making, natural language processing, and maybe relationship building. That pairing starts to create a very, very compelling capability that sort of takes the best sides of each system and minimizes the sides that don't work the best. So in our case, we were looking for 2 things. One, I wanted a well-known pain point, and by well-known, possibly something that we've been dealing with for a long time. We could have looked at some of the new innovation areas. I think the one that was most obvious is there's lots of signals, there's lots of events, we're connected to all these systems. Is there something around the threat detection, sort of posture side of things that's a good candidate? And I think those are fantastic use cases. However, I wanted the ability to look at how something is done today without an AI-assisted capability and compare that with something where that's involved, and to have a very obvious sort of assessment of like, were we able to improve things? So what we end up choosing was something that is, I think, a problem for most organizations, and this deals with access review and certification. Now, some of you are sitting there going, oh my God, you picked the probably least attractive use case in the identity space to have your innovation investment. And so hear me out about why we thought this was appropriate. Access review, as you all know in your organization, is a control that you do to basically verify the things that people can do is what they should be able to do. It is included in every compliance framework as a best practice. And at the same time, it is something that I think most organizations would say basically doesn't work very well. Now, if you unpack this, why is this the case? We've got a best practice that when it's done right is actually reducing entitlements and permissions of accounts in your enterprise. I mean, this is exactly dealing with this issue of over-privileged or over-entitled accounts. If I've got all these threat actors that are trying to compromise those accounts, it seems very plausible that I would focus on limiting what people can do. The problem is in the execution. And it's also in just the nature of where I think our enterprise has landed. So most access review campaigns are done by your frontline decision makers. So these are the managers or the BU owners in your organization. You're asking them what seems like a very simple question. Here's everyone in your organization. Here's everything they're allowed to do. Does that look correct? Now, for most of these leaders, this is a job they do periodically. You're asking them to use a tool that they don't use periodically. You're presenting them a lot of information that they may not understand. That's a function to one side of just the size of the applications that we have in the enterprise today. They're just more and more tools that we're using to automate the workforce. Two, how we inventory all those systems is actually quite poor. They're often not really well described. The managers looking at a description or a label or a very thin set of metadata to understand what a particular thing is doing, and then asking what feels like a very important question of, should you remove that access? I think most people are going to say, I don't want to break something that's working. Now, Radiant Logic, our history is in data management, and we've watched hundreds and thousands of these sort of access reviews occur over time. And we can do a very important step here is I'm able to see the data posture before a review is done, and then look at the data posture after a review is done, and have a simple question of how much of that data changed. Probably won't surprise most of you that very little gets changed. And in most organizations, the access review has become a rubber stamping process where managers receive an email with a very long list of entries of accounts and or people in their organization, many applications they have to step through, and they're being asked a very critical question of, should this access remain? Out of fear of doing something wrong, breaking the business, or stopping some process that's necessary for the business to run, they simply say, approve all, let's keep the data as it was last year. So this arguably ineffective process in our mind represented a great candidate. On the one hand, I've got this process deployed in a well-known fashion in the world. All kinds of organizations across all types of domains are doing this. I'm looking at the data as these campaigns execute, and I can see the level of data change, permission reduction, account deprovisioning that happens after these campaigns complete. And from a researcher perspective, it's a control group that I can use to compare the effectivity or the amount of change done with an AI assistant helping this process and one without. So this was our motivation. We were looking at a process way where I'm having complexity and data sets that they are having to review. And I'm supporting them with a capability that they don't necessarily have to be trained on. For us, this was Ada. Now, I'll introduce the concept of Ada and describe it in a bit of a use case as well. So Ada is our label for our AI data assistant. It is envisioned as if you had a consultant that is with your managers as they're going through their access review process. They are trained in cybersecurity best practices. They know the information about the data in this organization that every manager is going to be reviewing. And they're very familiar with the tool that the manager is being asked to use. It's really the three most important things you would want. The manager is going to go through the review process. And if I simply had a person that would sit with me, help me understand what I'm looking at, allow me to ask them some questions about that information, and perhaps have them make some suggestions to me about where to start, but allow me to ask some questions about their recommendations, I potentially would have the most effective type of access review that I've ever done. So our concept of Ada is exactly that. There's an implied set of steps based on best practices that suggests, let's look at all your data and let's start with the data that looks least concerning. Maybe it hasn't changed since the last review. Perhaps all the behavioral logs of what people are using suggest that what they have access to, they're actually making use of. There's a set of people in a population in your organization that just looks okay. And so we sort of move through a process of saying, I want to approve those accesses first. Does a couple things. One, it starts to reduce the amount of data that's left to be reviewed for the managers. And in some way, there's a little incentive to say, wow, I've already got a big chunk of this done, right? I'm sort of moving through my data set quite quickly. The other thing is the manager's getting a sense of accomplishment that they start to know the questions are being asked. And then Ada then goes in through a sequence of areas where there needs to be some more focus. And this is, I think, highlighting two very powerful capabilities of generative AI. One, it's able to look at data sets and understand relationships to answer why and what if questions. So an assistant that can present a set of data perhaps as a visual cluster, like you're seeing here, where I take information about groups and employees and describe that visually with the systems and permissions they have access to. The assistant can say, look at this information from this perspective. Let me group people that look very similar together into one set of information. And then you can see where there may be outliers or issues of people that look slightly different. So this is called cohort analysis or different types of statistical techniques. But two very, very necessary steps here. One, you want something that knows your data and knows the relationships of that data to navigate you through the process. Two, you want the ability to visualize that data in a way that's understandable. And probably most importantly, three, you want this thing that's helping you, it knows how to use the product that you're using to make your decision making. So we see this sort of tight interplay between looking at data, an implied workflow of steps, leading the reviewer through a set of questions, navigating them through different parts of the application that is depicting data in a different type of fashion. So the decision is very much informed, right? You've said, here's what I want you to look at. Here's a way of understanding the visualization of that data, suggesting that this is why I think A versus B, allowing the manager or the reviewer to ask a question, and then ultimately saying, I think this looks good. Let's move on to the next set of reviews or get down to your final set to complete the sign-off. We've had very, very strong reaction here in a bunch of the field testing we've done. In some organizations, the managers simply rely on the assistant to go through the suggestions and say, I think those look good. In other organizations, we tweak the process, right? This idea of sort of bulk approval, for some enterprises, that's something that they don't want to enable in their organization, because that's led to a lot of the problems that got them into the situation they were in the first place. But the idea of having a sort of very intelligent, well-trained assistant that I can ask questions of, that can pose questions back to me, that can suggest answers, or even suggest areas of data that you need to go find has become a very, very powerful, I think, experience. We're looking at additional use cases here, and I think this is where generative AI really starts to open up what could be done in the future. Because part of where I think large language models and the idea of inferencing about things becomes very powerful is the idea of it suggesting another set of data or information that it actually doesn't have that might be able to answer a question. So we've got a great example of this, for example, for a lot of organizations that are doing peer group analysis, they'll bring that information in from their directory sources. So your Active Directory or so your LDAP systems. And we all know those aren't the most up to date, right? You may have lots of identities or human and non-human that are sitting in groups. Those groups maybe aren't well labeled. So when you use that group as the only definition of what you call a peer group, or you take the organization of your company as the peer group, while useful, it's maybe largely incomplete. What we found is a lot more dynamic opportunity is some of the chat tools that are deployed in the enterprise. So think about something like a Slack or a Teams. When people work together on an effort, they often form a channel, and they'll collaborate within that channel on a type of topic. We're starting to see some trends now where that channel is maybe a better indicator of a working group, because you may find that the people in that channel are coming from different departments, and because they're from different departments, they have different accesses to systems, but what they share is they're working on an effort together, and that's why that group is actually the peer group that should be evaluated. Large language models have the ability to sort of ask that. It says, I don't have all the data to help you make this decision, but if you could go find this, it will help me get to a better type of decision. So I think there's tons of innovation for us moving forward in this idea of leveraging large language models in the AI space as it relates to identity data, and appreciating that there's lots of more systems that are producing some of that information to come to that decision. Heather, I'd like to invite you back on to see if we have any questions from the audience on sort of the use case area or applications of AI, how we have started.
Let's see, John, I There is a question actually that came in. You were going through the different use cases around using AI and IAM. A question came in about what makes you nervous about the way you see companies incorporating AI into IAM.
That's a good question. So when ChatGPT came on the market, I think most everyone saw this sort of renaissance of these companies that were producing AI capabilities that were powered by ChatGPT. And they were wrapping basically a use case or a specific domain problem around that. I think a big concern is the misselection of an AI approach to the problem set. So I talked about this a bit earlier. Generative AI has some areas where it's not particularly good at, and actually, when applied by itself without any type of shaping, scoping, or assistance, can lead you to a situation where the answer it's giving you looks very plausible, but is actually incorrect. If you think about the cyber and identity space, that's very risky for us. The last thing I think you want is an AI capability deployed to your workforce or to your decision makers that you're not quite sure if it's giving accurate information. So that's one sort of key thing, I think, is this sort of appreciation that data science is a broad area. AI fits inside of that. There are different AI techniques, and you definitely have to select the appropriate application for the problem space.
Okay, thank you. There was another question around what you wish you would have known when you were beginning to build the Copilot, the AI Copilot, but it sounds like based on the rest of your presentation, that's what you're going to be getting into next. So I will, I'll let you get to that, and then we should have some time for more questions at the end.
Thank you very much. I think that's a great transition to the final topic, which is some of the lessons learned. So first and foremost, I was in industry when cloud computing launched, and we moved from hypervisors to infrastructure as a service. I watched that entire market sort of evolve and completely change how not only have we built products as an industry, but how we actually ran our companies. I honestly feel like we're at a moment where this is that big of an innovation change for us happening in the space. The intersection, as I talked about, of hardware capabilities and GPUs with the software capabilities around really large model training, I think is going to unlock a set of computational opportunity to change the way we build technology and leverage it in our enterprises, where AI and machine learning will just become a part of products in the same way we expect a cloud or SaaS-like capability in the products that we already consume. 1 year journey for us, as I mentioned. Can you imagine starting an AI effort prior to ChatGPT and large language models being a thing, and then sort of have that innovation happen as you were in flight, and then sort of spending a bunch of time seeing how that innovation may change your early thinking or not? That was exactly our journey. And I'd like to share some of our lessons learned that came out of that journey for those of you that may be looking at this type of development yourself. So to pull back the curtain on Ada, the capability that you just saw in action, it is built on sort of three primary things. One, it is using data for our customers. So this is our customers' data that is sourced from various contributors. So this could be hierarchical data that's coming from, say, directories like Active Directory or LDAP. It could be relationship data that we persist as a graph. But these are, say, like the access chain. A person is a member of this group or account, which gives them the ability to do these following types of permissions. And you can sort of connect the relationships between those things. Here's everyone else that has those same types of permissions or is a member of that same type of group. And then time series data. And this is critically important in some of the use cases you just saw, where we're looking at how data changes over time and providing the ability to compare and model that data change. And that's very critical in the aspects of sort of anomaly detection. So we conceptualize those things as a lake, right? So they're kept in their sort of original form, be that hierarchical data, graph-based relationship data, or time series data, and that is the input to the assistant. We use a combination of multiple models, and we are fine-tuning them, and I'll talk a bit about some of the lessons of that fine-tuning. But taking large language models, fine-tuning them for our domain, teaching them some of the best practices of cybersecurity. And the teaching is done through techniques that I'll discuss where you're creating basically a knowledge base. So one of the key lessons is that the large language models only know what they know. And if they weren't trained in a specific domain, there are techniques to basically educate them on things they're unaware of. And I'll talk about those in just a second and how this all comes together. The other key takeaway is we don't remove the humans from the process. So these are still business users, as you just saw. They're going through a well-known business process, albeit that's been historically painful. And where the assistant is sort of taking their existing data, this is their specific customer data, leveraging what are known best practices on how to answer questions about access review, and then providing a remediation plan. So these are the things I want you to do. So lesson learned number 1. Implementing AI in access management, but really in any of the domains, is much more than just taking data and a large language model as its AI implementation, and somehow I have data that comes out the right side. This to some degree, I think, was to your question, Heather, right? Like, what do you say? You sort of worry is like this pattern, I think, has a lot of risk. If you've worked in data science before, or you have data science teams, they will tell you that a lot of the investment is not in the model as much as in the data staging. So there are significant and incredibly important steps to data staging, data cleansing, and data synthesis before you even get to the point where I'm looking at models and then marrying the model with your data to actually get into different types of results. There's a great deal of testing that is done here. We select models, and in our case, there are multiple models. You create these test data sets of known input response, which is what you use to test the models on for their accuracy. And there's a great deal of fine tuning to get that performance accuracy ratio sort of selected. Key takeaway though is that the data staging, data setup, critically important to that model to being effective. Lesson 2 is choose the right approach. And I think we've covered this in a couple of the examples previously, but take this maybe as the most telling example of this decision process. If you consider machine learning broadly as a spectrum, there's a left side of that domain, which is largely algorithm based. And there's a right side of that domain, which I will put here, is largely generative AI based. And what's very important in that continuum is how the results are determined and how repeatable they are. If you ever spent some time with some of the LLMs on the market, just in your day-to-day work experimenting, you may have noticed that if you ask a question that's almost exactly the same, but slightly different, you get what looks like a different answer. And that is an artifact and a remnant of generative AI in the way that it does its decision-making in its transformer architecture. And we describe that as it being non-deterministic. It's a very important takeaway. That means that given the exact same inputs, you do not always get the exact same outputs. To have a fully deterministic implementation, that is where algorithms are, that is actually their power, right? You build an algorithm that says on any given input, I'm guaranteed to get the same output. And in the middle lives machine learning, right? This is our ability to create models that produce known outcomes, but they're specifically trained on certain types of use cases. So the takeaway is you probably need a combination of all these things. In our case, there's absolutely a combination of algorithms, machine learning models, and generative AI. We leverage generative AI for a lot of the reasoning and sort of knowledge search, but the predictive nature of things and sort of things around risk scoring tend to be a lot more algorithmic. And that's reducing the hallucination problem and getting to a really, really repeatable set of accuracy in terms of the use case outcomes. I think the other consideration, if you're trying to build these things yourself, is just the cost of this work. So forget for a moment the manpower requirements of the skill sets of recruiting and retaining that if you don't have, say, organic data science teams. But themselves are quite large and they are expensive to run at scale. So you want to be mindful of how big a model that you need for the types of use cases that you are implementing. A lot of really interesting research happening today on small language models, and I'm expecting that to be a better trend, where we start to reduce how much we really need these models to understand, to be very much domain specific, and then you're going to get to a better sort of cost accuracy sort of ratio. This is a really surprising one, but it relates to this idea of the non-deterministic nature of large language models. So prompt engineering, that's a term we use for how you phrase the question to the large language model. And not surprisingly, there are many different techniques that have been explored in the market. I've given just a small sample of those on the right side. And these produce slightly nuanced outcomes. So part of what you're determining is like, how do I pose the question to the large language model in a way that's going to get the most accurate response? Some of that's on the data I'm presenting to it. Actually, some of it is in the manner in which I'm asking the question. A really fascinating takeaway in this prompt engineering space, and there's been a lot of innovation here as well, that what's called the preamble or the prompt can actually be quite large. In some of our early experimentation, these were like 10 to 15 paragraphs of prompts that describe to the large language model their persona. So how long have they been in the industry? What is their expertise? Here are some examples of decisions that you have made in the past, so you can learn your decision-making process. There was a point not too long ago where we were sort of jokingly say that the next most in-demand skill set may be script writers and theater majors, because this sort of persona building is like writing a play and describing to an actor or an actress, here's the person I want you to effectively impersonate. It's striking. It's really interesting reads. But these techniques have sort of been involving and evolving about how to persona set the LLM into exactly the posture and the way of thinking that you want them to execute on. Now, I will say that there's really good work happening here in the research world. For those of you that are interested in this, some great work happening out of Stanford, some frameworks, not the least of which is something known as DSPy, with some different programmatic techniques for the prompt engineering, but really focus on this idea of really driving accuracy. I mentioned that the large language models are trained on a large set of data that was generally from the public domain. And the inverse of this is what you have to appreciate is they just don't know what they don't know. So for really specific cyber-oriented aspects of our industry, they may not have been trained on a corpus of data that includes that information. There are techniques where you can create knowledge in a way that the large language model can reference. So think of this as like an encyclopedia that you make available to one of your experts. And you say, you get asked a question that maybe you're not quite familiar with. Here's a bunch of information that you can leverage. One of the most successful techniques in this is called RAG, or retrieval augmented generation. But conceptualize this as knowledge that you know that is specialized for your domain or for your particular install base or your threat environment, and you train and capture that knowledge in a way that the large language models can level. There's still a great deal of risk as you read about day in and day out. The risk actually exists in multiple layers. At the lowest level is just simply provider risk. Where are you getting your large language model capability from? Is that a third-party service? Are you using open source techniques and hosting it yourself? And then what training data was that model built on? Very important in the decision-making process as you make model selection. The question then of like, do I do these things myself? Do I leverage something third-party? That market is very much maturing and evolving, and I expect to see more and more players here. You're seeing the hyperscalers either play a role where they do model creation themselves, or they want to be a brokerage house of multiple models. So I think lots more to come there. And then there's all the sort of consumer side of the risk, right? So as you provide AI capabilities to your end users, they are interacting with models. And then there's a question of that interaction itself. Is that something that's captured and is private to the customer or that individual? Do you as a provider, do you keep those interactions? Are you able to train on those interactions over time? So there's a great deal of implication for those of you that are implementing AI to your end customers or in your products, to how you basically describe what you're doing and put out the terms and conditions of what you expect of how you're treating the data, what is private and what's going to be shared. Probably my biggest takeaway, and the area I'm most thrilled about, is the evolution of the open source community in this space. Early on, GPT-3 and that incredible innovation, what was state of the art. And anyone else that was doing anything else in that space was largely experimental. But we followed this evolution of the open source world and large language model options to the point that today, that's what I'm using for my production systems. We have seen the combination of multiple models, the ability to fine tune them. The open source community is at a level of velocity now where there are options. And there are multiple people participating here. You've got all the interesting stuff coming out of Meta, the donations that are happening from companies like Databricks, and then the existing players like Anthropic that are creating a really rich ecosystem of model development. On any given week, I see another announcement about another large language model that's dropped with a different parameter and hyperparameter set. And the great news there is that gives you choice, and as technology developers and integrators, that's the one thing that's most important to us. So big takeaway here is that the open source community is not to be ignored, specifically in this place. I think this is where we're going to see a great deal of more innovation. And I'm also thrilled to see the role that research is coming back in with academia. So there's a great paper clearinghouse called Archive that publishes papers that are research in nature that haven't completely been peer reviewed yet, but they're trying to get these papers to the community as fast as they can. And you can read about some incredible innovations and tests that are happening around these different types of model development, these different types of prompting techniques. And I think it's a great sort of marriage of traditional research that was separated from industry and that coming back together much more closely. And my last lesson takeaway is that at the end of the day, AI is only as good as the data that it's been trained on or that it's analyzing. So data hygiene is incredibly important either in the application of AI or the creation of AI. We see this as a sort of interplay of connecting data, cleaning that data, and then leveraging different types of data science capabilities to then get a set of prioritized risk-driven actions. But the data collection and the data hygiene piece, absolutely essential for this to be something that can be exercised. So I hope this has been helpful content for you. I hope you've done some takeaways around use cases. For those of you that are experimenting with AI techniques for your own product or innovation development, the lessons are going to be useful and applicable. And you have an appreciation for what's possible today and some of the other use cases that can come in the future. I want to close by saying thank you for your time. I know we're reaching for the top of the webinar, but also say that for those of you that will be attending the event in person, we have some really, really great keynote speakers coming to the conference. I have the distinct honor of presenting on the morning of day 2, which is on Wednesday. I'll be speaking about sort of my viewpoints on the evolving world of data and AI and the worlds of identity observability, but hope to meet many of you in person. And I want to extend my thanks to everyone that's attended today and is watching over the webcast. So thank you very much.